Geometry K5, side, 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 angle, side, angle, and angle, angle, angle theorems. On this one, we're going to be very, very careful with it. If you have side, 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 or angle, side, angle, or in, I think it's K11 where we have hypotenuse leg, all of those are talking about congruency. Okay, that means if you are using these, then if you're using them, then the triangles are congruent with the other triangles. If you are using angle, 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 if you don't have any sides, basically, if you know all three angles are the same, but you don't know anything about the sides, then all we know about angle, angle, angle is that they are similar. They're the same, exact same shape, but one is smaller than the other. One has been exposed to stuff. So on this, which rule explains why these triangles are congruent. So we have these two angles and this side. So we have a side, we have an angle. What else could we have? What we have is this angle right here is congruent to that angle right there. It's been a long, long time since we've used this information, but remember when two lines cross and you have angles that make the X, then those are called vertical angles. And vertical angles are always congruent on each other. So we have another angle. So we have a side, we have an angle, we have an angle. Now what order do we have that in? So is the side between the two angles? No. So we have angle, angle, side. Explain why. This one shouldn't need any explanation. It's side, side, side. Okay, and then explain which rules explain this. All right, see I did green and blue. If you separate these two triangles right here, and then the blue one, and then we don't look at this anymore, okay? So we know two angles again, but you're like, you need a side. Well, we do need a side, and I guess I shouldn't have said we don't look at the angles anymore, or that part anymore, because what happened to this side? Well, it went here, and it went here. So this side is congruent because it's the same side. So we have an angle, angle, side. Anytime I see two lines cross, I know we have vertical angles. We have an angle, we have a side, and we have a side because it goes in that order. Or if you go backwards, we have a side, side, and then an angle if we go backwards. But remember, we do not say dirty words, so there is not an angle, side, side. So these cannot be proven. The angle is exactly between the two sides. So this is side, angle, side. See that side right there? It's in both of them, so it's congruent about itself. So side, side, side. I see vertical angles. So I see an angle, side, angle. Is angle, side, angle one of these? Yes. So yes, it can be proven. We got to be very careful though about this one, okay? Just like I said earlier. Can you prove? So we have a side congruent to itself, so we have side, angle, side. We do have a side, angle, side, so that's a yes. And on this one, kind of what I've been preaching about here on this one, we have three angles. We have an angle, angle, angle. But an angle, angle, angle only means that the side or the triangles are the same shape, but they're not necessarily the same size. So there is no side that we know of, so we can't determine that it's congruent. We only know that it is similar. So there is not enough information.